Hello everyone, welcome to today's presentation. I'm excited to introduce our topic, coordinate geometry. On this first slide, we see the title, which sets the stage for what we'll explore together. We'll be looking at the fundamentals of coordinate geometry, its applications, and how it connects algebra and geometry. In the next few slides, we'll cover key concepts, methods, and some real-world examples. So let's get started and dive into the fascinating world of coordinate geometry. Let's take a closer look at the key points on this slide. First, we'll explore what coordinate geometry actually is. It's a branch of mathematics that helps us locate points and understand shapes using numbers and axes. Then, we move on to the concept of the Cartesian plane, which is the foundation for plotting points in a two-dimensional space. Next, we discuss what a quadrant is. These are the four sections of the coordinate plane divided by the axes, and each quadrant has its own characteristics. We'll also look at some basic conventions we follow when working with coordinates, like how to write points as x, y, and what positive or negative signs mean in different quadrants. Understanding these foundational points is crucial because they set the stage for grasping the formulas and methods used in coordinate geometry. This slide provides the groundwork for everything to come, connecting the idea of plotting points with the broader mathematical concepts you'll be learning. Let's take a closer look at the overview of the section formula applications. First, we'll explore the section formula itself, which is a powerful tool for finding a point that divides a segment in a given ratio. Next, we'll identify the four quadrants in the coordinate plane, which helps us understand the position of points relative to the origin. Then, we'll describe the coordinate plane and discuss why it's so important in graphing and analyzing geometric figures. Finally, we'll go over the Cartesian coordinate system, which is the foundation for plotting points and understanding the relationships between them. Throughout this section, we'll see how these concepts connect and support our overall understanding of coordinate geometry. In honor of his work, the coordinates of a point are often called its Cartesian coordinates, and the entire coordinate plane is known as the Cartesian coordinate plane. This approach is what we refer to as coordinate geometry. The key idea here is that it provides a systematic way to describe the location of points in a plane using ordered pairs of numbers. This method was actually proposed by the French mathematician René Descartes, who made a significant breakthrough by linking algebra and geometry. He suggested that not only can we pinpoint points using pairs of numbers, but we can also describe curves and lines with equations based on this technique. This was a huge step forward because it allowed us to analyze geometric shapes algebraically, opening up many new possibilities in mathematics. So, in short, coordinate geometry is a system where the position of any point on the plane is represented through an ordered pair of numbers, giving us a powerful tool to explore and understand the relationships between points, lines, and curves in a very precise way. Let's take a closer look at what a Cartesian plane is. Named after the French mathematician René Descartes, who helped formalize its use in mathematics, the Cartesian plane is essentially a two-dimensional space. It's defined by two perpendicular number lines, the x-axis, which runs horizontally, and the y-axis, which runs vertically. These axes intersect at a point called the origin. Using these axes, we can describe any point in the plane with an ordered pair of numbers. This system allows us to plot points precisely and analyze their positions relative to the axes. The Cartesian coordinate system is fundamental because it provides a clear, consistent way to locate and graph points, making it essential for many areas of mathematics and science. This understanding forms the basis for more complex concepts we'll explore later in this presentation. Let's take a closer look at the coordinate plane. This is a two-dimensional space, which means it has two directions, horizontal and vertical. The horizontal line is called the x-axis, and it runs left to right. The vertical line is called the y-axis, and it runs up and down. These two lines are perpendicular, meaning they meet at a right angle. They intersect at a specific point called the origin, which is where both axes are zero. Now, these axes divide the entire coordinate plane into four equal parts. Each of these parts is known as a quadrant. Understanding these quadrants is fundamental because they help us locate points and analyze their positions relative to the origin. So, as we move forward, keep in mind that these quadrants provide a helpful way to organize and interpret coordinates in the plane. Let's take a closer look at the coordinate plane, which is also known as the Cartesian plane. This is a two-dimensional surface where we can plot points, lines, and shapes. The two axes that divide this plane are called the coordinate axes, the x-axis and the y-axis. The x-axis runs horizontally, and to the right of the origin, which we denote as O, it is called the positive x-axis. Conversely, the part of the x-axis to the left of the origin is the negative x-axis. Similarly, the y-axis runs vertically. The part above the origin is the positive y-axis, and the part below the origin is the negative y-axis. Now, the plane is divided into 4 equal sections called quadrants. These are Quadrant 1, Quadrant 2, Quadrant 3, and Quadrant 4. Each quadrant helps us locate points based on their signs of x and y coordinates. Understanding these divisions and axes is fundamental because they form the foundation for graphing and analyzing functions and geometric figures on the plane. They connect directly to the overall theme of understanding how points and shapes relate to a coordinate system. Let's talk about the coordinates of points on a plane. When we consider a point on the x-axis, it has an x-coordinate, which is the x value, and a y-coordinate of 0. Similarly, a point on the y-axis has a y-coordinate, and its x-coordinate is 0. The key idea here is that the point's position is described by these coordinates. For a point on the x-axis, it's x, 0, and for a point on the y-axis, it's 0, y. Now, the distance from a point to the x-axis is called its y-coordinate or ordinate. Think of it as how far up or down the point is from the x-axis. Conversely, the distance from the point to the y-axis is called its x-coordinate or abscissa. This tells us how far left or right the point is from the y-axis. To accurately locate any point on a plane, we need a pair of coordinate axes, an x-axis and a y-axis. These axes serve as our reference lines, allowing us to pinpoint the exact position of any point using its coordinates. This fundamental concept is essential for understanding how we work with points and graphs in the coordinate plane. Let's start by plotting the number 1 on the x-coordinate, since it comes first in the ordered pair. Because 1 is a positive number, it moves us 1 unit from the origin to the right. Next, we plot the number 3 on the y-axis. Since 3 is also positive, it moves us 3 units up along the y-axis. The point we end up with, 1, 3, is represented graphically in the figure. When we talk about the coordinates of a point in the coordinate plane, remember that the x-coordinate always comes first, followed by the y-coordinate. We write these in brackets as x, y. The y-coordinate, or ordinate, is the perpendicular distance of the point from the x-axis, measured along the y-axis. Conversely, the x-coordinate, or abscissa, is the perpendicular distance from the y-axis, measured along the x-axis. Understanding these conventions is key because they form the foundation of how we describe and locate points in the coordinate plane. This helps us connect the graphical representation to the mathematical notation, making it easier to analyze and interpret data visually and numerically. So to clarify this important point about ordered pairs, if x is not equal to y, then the ordered pair x, y is not the same as y, x. In other words, the order matters when the elements are different. But if x equals y, then the pair x, y is equal to y, x. This highlights that when the two elements are the same, the order doesn't make a difference. Understanding this distinction is crucial because it underpins many concepts in coordinate geometry, especially when dealing with points and their relationships. It helps us remember that the position within the pair is significant, whether we're talking about points, coordinates, or other mathematical constructs. Connecting this to the overall theme, grasping how ordered pairs work is foundational for understanding how we represent and interpret points in the coordinate plane.